Hello my dear students, this is Akash HD and welcome to the HD Physics classes. Hope so you all are doing really great. So students, in this video we are going to learn about the derivation of drift velocity. And to learn the drift velocity derivation, we should know very well how the conductor will behave. Conductor means like aluminum, copper and all that. How it will behave means when it is connected to the battery, how the electrons inside the conductor will move, and when it is not connected to battery, how the free electrons inside these conductors and all will move. Okay, so all these things we are going to learn in this video, and let's start the video. Okay, so see here students. So under the derivation of the drift velocity, first let's see, we are going to see when the conductor is not connected to battery. Okay, so let's see here. As free electrons in a conductor gain energy due to temperature of surrounding and move randomly in the conductor in the absence of battery. Again I am telling that here, when this conductor is present at a room temperature, then free electrons will do which motion? Random motion. Again I am telling at room temperature. Okay, so here students, here I have taken one conductor, and you know very well when the free electrons will come out of the atom, then what will happen? As the electron is negative, so this atom that will lose the electron, it will become ion. Which ion? Positive ion, and that I have represented here. And even this kind of ions are called immobile positive ion. Okay, because they will be fixed inside the conductor, and free electrons, as the name itself suggests, it will move. So here what will happen, that you see average velocity of random moving electrons. What I am telling, see electrons, random moving electrons is 0 at any instant, because in a conductor how many electrons? So many electrons are there, and they will do which motion? Random motion. Just like air molecules, they move here, there randomly in a in a room. Similarly, the free electrons in the conductor, they will randomly, it will move. So here I have taken some ions is there. So here please, here if I take one electron, let's take it is moving in this direction. Now similarly here if I take one electron, this is moving in this direction. Okay, this electron in this direction, this electron in this direction, this electron in this direction, and this electron in this direction. So what is happening that here students, all these electrons, what I am telling, this all these free electrons, all these free electrons, they are doing which motion? Random motion. Okay, and at any instant, velocity of all these electrons at any instant, how much? 0. So what will happen that here, as the velocity of all these electrons at any instant is 0, that's why if the conductor is not connected to battery, what will happen? The current through the conductor will be 0, because you know very well the current means what happens, that the charged particles are moving. Here also the charged particles are moving, but they are not moving in any one specific direction. That's why the resultant of all of the free electrons will be 0, and how much current it will constitute? It will constitute 0 current. That's why when the conductor is not connected to battery, what will happen? There is no current through the conductor. Okay, so now students, here up to this we was talking about the electrons at any instant. Now see here, electrons at any instant. Now here onwards we are going to focus on a single electron, and we are going to calculate the drift velocity of a single electron when it is going to connect with the battery. Okay, so first we are going to see when the conductor is not connected to battery, and how a free electron will move. Okay, so see here please, see, let velocity of an electron is u1, u2, u3, un after first, second, third and nth collision respectively is there. Now see here, an electron, a single electron. Now see, average velocity of the electron is given by, so see here students, here I have taken the some ion. Now one positive ion is there. So what will happen that here, when a single electron, it will do collision with this positive ion, let's take here, it is going in this direction. With how much velocity? Let's take the velocity is u1. Okay, after that what is happening, that let's take here again, it has done collision with the another positive ion, and after that what is happening, it is going in some any direction. Let's take here, it is going in this direction with velocity u2. Okay, again what is happening, again the collision is happening, with the fixed ion, and then what is happening, that let's take the electron, it went in this direction with velocity u3. Okay, and just like that it will keep on continue. Again let's take this positive ion is there, and what is happening, that here again the electron is will go in some other direction. Na? So let's take, maybe for the example, it went in some this direction here. Okay, and velocity how much here? u4. Okay, and I will just draw one more here. Let's do one more. let's take again, this positive ion collision happened, and let's take what happened, this electron went in this direction. Now, just let me change the color, and this electron went in this direction with how much velocity? u5. So here you can see very well, a electron inside the conductor, it is doing which motion? A random motion, this side, this side, this side, this side, here, there, it is moving. Okay, so what will happen that here, average velocity of this electron, see, let me write here, this u average. Now, u average, it will be how much is there? If I will write here, see, this is u1 plus u2 plus u3 plus dot 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 plus un by n. Now, average velocity of this electron is how much? 0 is there. Now, you can see very well, students. In first diagram, we are talking about the collection of so many electrons at a time. But in second diagram, we are focusing on a single electron, how a single electron is moving, because we cannot focus so many electrons at a time. That's why we are focusing on a single electron, how a single electron is behaving. In the same way, we can predict for the another electrons also. Okay, so this equation, kindly remember that here, now this one, and I have made it here equation 1. Kindly remember this one. Okay, after that, students, what we are going to do? Next one, see. Up to this, what was there? The electron, this conductor was not connected to the battery. Now what we will do? This conductor is going to connect with the battery. So see how it will do. See, again, when the conductor is connected to battery, then the electron will move in which path? Zigzag path. Remember that. And will drift towards the positive terminal of the battery as shown in diagram. Now, so now what has happened that here? This conductor is there, now we have connected to the battery. This is plus terminal, this is minus terminal. So this end of the conductor is positive and this end of the conductor is what? Negative. And because of this, one electric field will create inside the conductor from where to where? From positive end of the conductor to the negative end of the conductor. And this electric field I am writing here E. Okay. So here what is happening at here, students, here again I am going to focus a single electron. So what is happening at here? Let's take here one ion is there, positive ion. Okay, so what is happening at here? This electron is having velocity in which direction? This direction, v1. Why I am telling v1? Because see here, electron is having which kind of charge? Negative charge. And you know very well, negative charge always moves in which direction? In the opposite direction of the electric field. So you know very well, electric field which direction? Right side. That means electrons are having the tendency to move which side? Left side, in the opposite direction. Okay, that's why I have drawn like this. Okay, after that what will happen at here? Again, when it will move electron, again it will collide with another positive ion. Now, and after that what is happening? Let's take, because of that this electron went in this direction with the velocity how much? v2. Okay, similarly again what will happen at here? See, again the collision has happened, and because of that what is happening that here? Let's take again, electron went in this direction with how much velocity? v3. Okay, and again let's take, see, collision is keep on happening. Again it is there, again collision happened, and let's take now the electron is going in this direction with velocity v4. One more. No, again see here, again positive ion collision, and what is happening that? Let's take now the electron is going in this direction. So here the students, you can see very well, here the electrons are not doing the random motion. Why? Because here you can see the electron is moving from which terminal to which terminal? Negative end of the conductor to the positive end of the conductor. Why? Because electron is negative, that's why they are moving in this direction. And it is which kind of path? It is the, see here, zigzag path, not a random path. Which path? Zigzag path. Random means maybe left side, right side, upside, downside, but here electron is having one specific direction. Which direction? Left side to the right side, or we can tell negative end to the positive end. Please remember that very well. And here one term is their drift. Drift means what will happen that, students? Drift means actually the speed of the electron, or we can tell the velocity of the electron is not increasing continuously. Why? Because the moment velocity of the electron is increasing somewhat, that time itself collision is happening. Then again velocity will decrease. Again because of this electric field, velocity will increase, and again collision will happen. Then again velocity will become 0. Again velocity will increase, then again collision will happen. So here what is happening that the velocity of the electron is not increasing continuously. It is the drifting. Even you can imagine in that way, like let's take for example 3 breakers are there and one car is there. So do you think the speed of the car can increase continuously? No, because the moment speed of the car will increase, one breaker will come, then speed have to decrease. The moment breaker will cross, again car will increase the speed, then again second breaker will come, is it? Then again have to decrease the speed. The moment second breaker will cross, car will increase the speed, again third breaker will come. So here what is happening at, the car speed is not increasing continuously, the speed is the drifting. So in the same way what is happening, that the speed of the electron is not increasing continuously. What is happening? It is drifting because of the regular collisions with the fixed immobile positive ions. Okay, and here I will just represent here, see this is the electrons are there, so that you should not get confused. Here electrons are there. Okay, great. So remember that. Which path? Zigzag path. After that, see here please, see. Acceleration acting on each electron is given by, as I have told you, electrons are accelerating in which direction? Negative and to the positive end. So this acceleration is given by, you know very well, from the Newton's second law of motion. Acceleration A equal to F by N, because we know F equal to ma, is it? So we know this one as. So here we can write here, F means you know E equal to F by Q. So F equal to QE. Electron is having the charge, minus charge. Electric field is E, and here by M. This is the acceleration acting on each electron. Even on a single electron or any electrons are there, all of them are having same acceleration. Okay, and this acceleration is, remember that here, this acceleration is the uniform acceleration. Acceleration is uniform. Velocity may be keep on changing because of the collision. Acceleration is uniform. That's why we can use here the equations of motion, that we will use it. Okay students, so kindly see here very well how the electrons are moving in a zigzag path. As of now we have made how many equations? We have made the 2 equations. Okay, great. Now we are going to see what is the drift velocity. So see here very well. Drift velocity definition is also very important. Okay, so see here. Drift velocity is the average velocity with which a free electron in a conductor get drifted towards the positive terminal of the battery under the influence of the electric field. Okay, drifting where? Towards the positive terminal of the battery, because electron is negative charge moving from the low potential to the high potential, negative to the positive. So the drift velocity of the electron is given by, remember that here, drift velocity is given by, students, see the formula. This Vd is equal to, what is there? After first collision, velocity of the electron is V1. After second collision, V2. After third collision, V3. ... Let's take after nth collision, Vn. By n, number of collisions. Okay, so this is the general formula. If they ask the drift velocity definition in formula, write the definition and write this formula. But we are doing the derivation. Okay, so students, you know very well what is the first equation of the motion? V equal to U plus AT. Okay, so that we are going to use this here. So what will happen that here, see, this V1 is given by U1 plus acceleration into tau 1. What is tau 1? Tau 1 is the time taken just after the first collision. Okay, remember that here. Plus V2 means here U2 plus vector A into tau 2. Okay, plus ... And what we can write here, see, Un plus vector A into tau n. Okay, and after that what is there? By n is there. Now can you see this? This is 1 and this is 1 and this is 1. Okay, so what is the tau 1? Relaxation time. This tau 1 is called the relaxation time just after the first collision. Okay, even if I write here the relaxation time, students, I can write here, see here the relaxation time, here the tau 1, here the relaxation time is what? Tau 2, here relaxation time tau 3, here tau 4, and similarly for this we can write here the tau 5. So like this it will keep on continue the relaxation time. Okay, remember that. So after that what will happen that here, students, we are just going to separate this. First we'll separate here the velocity. So see, u1 plus u2 plus un by n. Okay, this is 1 plus vector A, and what we can write here, relaxation times and all, tau 1 plus tau 2 plus ... plus tau n by n. Okay, so this one we have got here the drift velocity. Now you know very well, students, from the equation 1, this term is how much? 0. See here, I have written, see, equation 1, this average velocity of the electron, how much here? 0. Okay, and after that here, see, the vector A value is this also. Both these equations we are going to use next one here. Okay, kindly see here very well how we are going ahead. Okay, so see here, students, Next one we are just going to write here. See, this is given by this here. This drift velocity is given by 0 plus vector a into tau. This is the average relaxation time. Okay, and if I write here, I can write here this Vd is equal to, what is the value of a minus e vector e by m into tau. So if I will simplify this, it will come here, drift velocity means c minus e tau by m into vector e. Okay, what is this, students? This is the drift velocity of electron that we have got by calculating the average velocity of the electron when it is connected to the battery. Okay, after that, if I talk about here the magnitude, now this is a vector form, but if I talk about here the magnitude, so this magnitude is given by Vd equal to e tau by m into e. Okay, there is a no vector sign, no minus sign and all that here. Okay, so remember that here. Vector sign tells that drift velocity is in the opposite direction of the electric field because minus sign is there. But the magnitude means no vector and all that. Okay, great. After the students here, please, this one note under the note C. Order of drift velocity of an electron in a conductor is how much here? 10 to the power minus 4 meter per second. How much here? Very, very small. Remember the value. 10 to the power minus 4 meter per second here. Okay. And if in case I talk about here this is the drift velocity. But if I talk about here the thermal speed. Which speed, students, here? The thermal speed. I'm talking about here. Okay. Thermal speed. So this thermal speed of the electron is used to be of the order of 10 to the power 5 meter per second order. Okay, speed, that is the velocity. Direction is considered. Here what is there? Speed, remember that here. Okay, so students, you can see very well here. Remember that here, drift velocity order 10 to the power minus 4 meter per second, and thermal velocity how much here? 10 to the power 5 meter per second. Okay, and here even you can remember this formula also. This used to be root 3 kT by m. At room temperature you can take T 300 Kelvin. Okay, but now you may think one thing, like if the drift velocity of the electron is very small, then when we are switching on, whenever we are switching on, any bulb can glow suddenly. How? Why? Because see here, what happens that here, let's take for example, this is the bulb. Okay, and here one switch is there and it is connected to the battery. Okay, this is the bulb is there. Now this is bulb is there. So what will happen that here, the moment we will make the switch on, what will happen? Suddenly this bulb will glow. But you can think very well. You can think, okay, the drift velocity is only 10 to the power minus 4 meter per second square. Then it should take some time to glow. Not like that. What happens that the moment we are making the switch on, wherever electron is present inside the conductor, it starts to drift. That moment itself. Okay, this happens suddenly. So what will happen at here, students? If we draw here the electrons, now here these electrons are there, now these electrons. See this one here. The moment we will make the switch on, these electrons will start to drift. In which direction? You know very well. Which end to which end? Negative end to the positive end. This is the negative, this is the positive. So what will happen that here? This electron will start to drift. In which direction? In this direction. Suddenly electrons will start to drift and the bulb will glow here. Okay. So remember that here, this thing very well. What is the drift velocity order, thermal speed order, and all these things. Okay, great. K is the Boltzmann constant and m is the mass of the electron. This also remember that here. Okay, great. After that, students, we have done the derivation of the drift velocity, important for the 3 marks in board exam. Very important. Okay. Now you see mean free path. So what is the mean free path? See, it is the average distance traveled by an electron between 2 successive collisions is there. Okay. So if I write here this lambda average. Okay, mean free path lambda, you can write lambda average. So let's take after first collision lambda 1, after second collision distance traveled lambda 2, after third collision lambda 3 ... plus lambda n by n. This is called what? Mean free path, or what we can tell, average free path. Okay, and if I go in a back direction also somewhat little bit, so see here, please, here if I talk about here, remember that here this will be lambda 1, this will be lambda 2, lambda 3, lambda 4, lambda 5. All this average will take and will get it here. Okay, that means during tau 1, lambda 1, during tau 2, lambda 2, during tau 3, lambda 3, like this. Okay, remember that. After that, see, note, order of mean free path of an electron in a conductor is how much? 10 angstrom. That much small distance is there. Okay, order 10 angstrom, mean free path or average free path is there. Kindly remember that very well. Okay, now after that, students, see the next one. What is there? The next one we are going to see mean relaxation time. So see here, as I have told you, it is the average time taken by an electron between two successive collisions. So if I write here, this tau average is given by tau 1, you know very well, relaxation time after first collision, relaxation time after second collision, relaxation time after third collision, plus tau n after nth collision by n. This is called the average relaxation time. And remember that one more thing, students, relation between relaxation time and the temperature. So what happens that here, this relaxation time is inversely proportional to temperature. Okay, because what will happen that here, the moment you will increase the temperature of any conductor, the electrons will start to move fast. So when they will move fast, the relaxation time will decrease. That's why this is inversely proportional to the temperature. Kindly remember that very well. Okay, now if we talk about here order, so order of mean relaxation time of an electron in a conductor is how much here? 10 to the power minus 14 seconds. Remember the value, they may ask in exam. Okay, so kindly see here very well what is the relaxation time, and it is inversely proportional to the temperature. Temperature we will increase, mean relaxation time will decrease, and vice versa. Okay, great. Now we are going to see mobility. Some important term is there, they may ask. It is defined as the drift velocity per unit electric field of an electron in a conductor. Okay, and mathematically if I write here, see, it is given by this mu equal to Vd by E. What is this? Mu equal to Vd by E. After that, students, you know very well, I have taught you, what I have taught you, see, Vd equal to E tau by m into E. Remember, this I have taught you no, under the derivation when I have written the magnitude. So from here, if you will see Vd by E, it will come what? It will come here E tau by m. So this mu I can write here, see, E tau by m. Remember that here. Okay, mu. Mobility is there. Okay, great. Remember that here. Now after that, see here, students, some important points are there. See, first one, mobility is independent of the applied electric field. Now it is the property of the what to tell, carrier, maybe electron. In semiconductor you will learn holes, that so it does not depend upon the electric field, whether the mobility of the electron, mobility of the hole, it does not depend upon the electric field. Okay, second one, SI unit. So students, what is the SI unit? So if I write here the SI unit, even no need to remember that here, see, even I can make from here. Vd means we can write here meter per second. Okay, and electric field means Newton per coulomb or volt per meter also. So here I will write here, see, volt per meter. So when you will simplify this, what this will become here? Meter per second into this will become reverse, meter per volt. So what will happen from there? You can write here, it is given by meter square per volt second. Now meter square per volt second. Okay, dimensional formula. Sometimes they will ask the dimensional formula also. How to get the dimensional formula? So see here very well. If I have to get the dimensional formula, I have to use this. So see, you know very well, this mu is given by drift velocity Vd, and electric field is given by E equal to, we can write F by Q. I told you Newton per coulomb. So this is the very easy, F by Q. That means Vd into Q by F. Okay. So now students, after that, if I write here the dimensional formula, that means we have to write here in a big bracket always. So what this will happen that here, see, Vd means velocity Lt minus 1, charge is Q, that means At, and force is given by mLt power minus 2. Okay, so when we will simplify this, first let's see what other things will cancel out. This L and this L will cancel out. So we can write here m will go up, that means m power minus 1. Okay, and after that what will happen that here, see here, let's collect that t. So see, this t minus 1 and this t power 1, that will cancel out. So this t power minus 2 will go up. So we can write here t power 2. And what happened? LL cancelled out, so L power 0. And what about the A? Here only A is there. That means what is there? A power 1. So you can see very well, this is the dimensional formula of the mobility. So students, kindly see very well and remember that this mobility is independent of the applied electric field, whether electrons or holes. Remember that here, na, holes will learn in a semiconductor. So students, in this video we have learned about the derivations of the electric field. Practice it very well, important for the exam and other basics and all that. Okay students, keep studying, keep growing.